We can start with whenever you folks are ready. With
Yes.
BoF 1143, interoperability of users, developers, and managers. Whenever you folks are ready, take it away.
All right. Good afternoon, everybody, or wherever you are in the world. Good day. This subject we dealt with last year, but then we had a normal session where we were in a room together and we could actually talk. And I could see who was putting up his hand. That was much easier than we have now. So today you have to bear with us that it's going to be a little bit more messy, and maybe it's not going to be easy to have a good discussion. Because, wait a second, yes. Here's my favorite cartoon, which shows you ineffective managers, users and developers who have not discovered yet that they have wings. And so if we do things properly, then I hope people will discover that they have wings and will be like the birds in the sky that actually can be much more effective. So this is, of course, a Far Side cartoon by Gary Larson, who I greatly admire. So I'll start to say that this session is actually a fad tradition. We used to have many years ago, on the last Friday of ADASS, we used to have an afternoon where we allowed people to grandstand a bit. So we had a bit of an introduction, and then we allowed everybody to get up and give very profound comments. And somehow software people like that very much. So it was a big success. It was very popular. Of course, nothing came of it, but it was very nice. So today we continue the tradition. Actually, we did this last year already with roughly the same subject. And we would like to do it now. But of course, as I said, with the technological online thingies, it's going to be more difficult to have a decent discussion. So I hope that we can do something. Let's see, do this. So the format of this BoF, hoping that online discussion works. So we have prepared a series of slides that, this is one of them. And we were going to ask you to fill in Zoom polls, but Zoom polls are not part of this technology, so we're not going to use them. But there's some other thing that my two colleagues know about, and maybe that will work. We'll get to that in a moment. We were also going to use Zoom chats, but they don't seem to be available either. But it's a pity, because then maybe all the profound remarks from the audience will not be recorded. Well, let's continue. There's some more information. There's a suggestion to turn on your Zoom video so that we can see each other, which gives a bit more of a community idea. Shall I give you a minute to do that?
And Jan, while you're at it, Oleg would like to say something. So Oleg, go ahead.
All right.
No, I just raised my hand, Jan, to make sure you see me, in case you want me to say something.
Oh.
Okay, but you're on the panelists.
Am I on the panelist? Oh, okay. No, I'm not.
Yeah. But okay.
I've got a participant view.
Do you say anything? I can't see your face.
I've got a participant view for some reason.
Oh, should he be a panelist? I didn't know that. I'm happy
Can only the panelists be displayed?
Yes.
This is going to be even more troublesome.
Well, if we had everybody display themselves, that would be a very complicated display. Jan, should we? Yeah, thank you.
I just made him a panelist. Yeah. I will also try to spotlight him, because it's nice if we can see all panelists, I think. All panelists who should be talking.
There I am. And there you are. Okay, never mind. Sorry, didn't mean to interrupt.
So, where are we? Is Oleg going to say something?
I've said my piece. Carry on, please.
Did you say something? I couldn't understand it.
I said I've said my piece. Please carry on.
Okay. Thank you. Well, the slides that I'm now showing, we will probably not get through them all today. The ones at the end, the latter half is actually a bit of a bonus, and so they are available, and you can download them now or somewhat later. And the URL is here, and but you can ask for me. You can ask me later if you're interested to download them. The polls. Nou ja, Jan Grange will tell you what to do when we get to them. So the target birds of this BoF are 3 groups of people, scientific users of our software, and they are more important than they think, because they are gradually being moved to the fringes by the way we present the software to them, and so they find it more and more difficult to provide feedback, and so they don't, and that's a great pity. That's one of the subjects of today. Then we have software managers, and last year they totally dominated the discussions, and that was a pity, because of course the developers in the room are much more shy people, and they allow themselves to be pushed away. So please, managers, give them a chance. And so the software developers, it's all about you, really. So speak up within the possibilities of Zoom. Now here we have a poll, and so we can test whether that's going to work. So the idea was that we have you already filled them in?
Well, the link was already on Discord, but
I just put a fresh link in the Discord chat.
Okay, so people are now filling them in. How fascinating! I'm very pleased with this.
But how do we see the results? Then Jan needs a web display somewhere.
Yeah, I can see the result. It's interesting that nobody owns up to being a consumer of science-ready data products, but of course there may be not too many users in the audience, and nobody is bored.
I find it a bit limiting that you can only be one thing. Some of us have to do many things.
No, pick the best. We argued about this too.
So Oleg, what have you put yourself down as?
Well, I said algorithm developer, you know, wishful thinking, aspirational thinking.
All right, I consider you a scientific power user.
I'd like to be a consumer. I would love to be a consumer. Never happened.
Have you now? This is the one that is you?
No.
Okay. Oh, this is fascinating. It's much too fascinating. I can look at this forever. I think we have to move on. So we have a fair number of developers, and I'm very glad that we have a number of people that call themselves support scientists, because one of the points I'm going to make is that support scientists should be also a sort of developer, and we should make it easy for them to be developers, because they can do much more support if they can write their little applications to help people and to judge data. And so I'm very glad that there's lots of people in the audience that do that. Okay,
Has
shall
the
we move
poll
on?
stabilized, Jan? Has the poll stabilized?
yes, it looks rather stabilizing. There's already 83 people filling it in. I see some people asking questions. I can't find the link. So on the top of the page, you also see written down that you can go to menti.com and type in the code that's written there. Else, the link is in the Discord that comes with this BoF, which has a very long name. So I tried typing it in as an answer to one of the Q&A questions.
In any case, you've got 84 responses, and I hope this is going to be saved somewhere.
Yes, that's one of the nice things.
That will go in the report. Shall I continue?
Yes, so now you have to reshare your screen and you will be able to
Reshare?
Yeah, just share your screen again. Click new share. It will
Okay.
tell you that I am sharing your screen and you can take it away from me.
I have shared my screen. Nothing is happening. Oh, you cannot start screen share while the other participant is sharing. Okay, so you guys have to go out
Again.
first. Can I share now?
Yes.
Ah, here we go again. But now it's very small. Oh yeah, I do this one, and then I share. Good. Okay, that was more than 1 minute, but I think it was worth it. So scientific users, I want to get them out of the way so we can talk about developers. So I really feel that they are more important than they think for the reasons I just mentioned. And so I estimate that very soon 80% of them will be consumers of science-ready data products. And these science-ready data products are going to be produced by huge pipelines that the user certainly cannot touch and very often will not really understand. So that's a pity. So our hopes are on the 10% of support scientists who should really also be can-do developers, and that we should make it easy for them to be like that, much easier than it is now. And 10%, of course, are the power users, and they are the ones that should judge the quality of the results that come out of the pipelines and out of the telescopes. And they should push the limits. And of course, traditionally they have done that, but only a very small number of power users. But we should really take them very seriously, and developers should be responsive to those power users, because that is the way to make progress. Is there anybody who wants to say something about this subject? No.
Feel free to raise your hand if you want to say something, or type it in the Q&A.
Is the person who raises the hand, does he or she automatically go to the top of the list?
Yes,
Yes.
they do.
Okay, so I'll keep an eye on the top of the list. Ah, yes. All right. Oh, yeah, this was a test. Thank you very much. Okay, we continue. Okay, so we have another poll.
That's me. So the strange thing is I can steal your screen sharing. So I think, let's see what happens now. I can probably go here, and then I go to my own Menti, and I can say, because this is of course still the old one, we're already almost at 100.
99.
And the question is, how do I go to the next slide? There we are. And I think that now the question should have changed for everybody who clicks on the same link and or opens Menti with the same code. And I see that one power user already answered. So the Menti power user.
A victim. See, I didn't put
so
it there
just
for nothing.
refresh that last link. Refresh the last link.
Again, the support scientists are excellent. And of course, there's this category of other, but we have no room to investigate them. AT. The testers are very glad that we put in that category.
We're at 91 now. I think we're almost stabilizing, I would say. 1992. It's a bit like making popcorn, right? You have to just sort of wait until the when does it stop popping? Well,
Actually, this is
pops in
more
a row.
fun than I anticipated. So I'm very glad how this pans out. I think we should move on, shall we?
Yes.
Okay.
And we
So
unshare.
you will go out and I will share. I will share the screen again. Here we go. And now we share. You know, this technology might actually work in the end. So the full disclosure is that our background is in radio astronomy, which is highly compute intensive, maybe the most compute intensive of all the radio astronomy fields, all the astronomy fields. But the issues, of course, should apply to other fields also, because they also have users and developers and managers. We actually do have an axe to grind, in the sense that we have a solution to the problems we're trying to sell. But we would like to hear from you first. So today's premise, because we must always have a premise to focus the discussion a bit. We're talking about data processing software, and that of course is the software that deals with the end product. Many people that write very important software for the infrastructure, and we're not really talking about them. And it's the end product, of course, that that is closest to the user, and so there should be an interaction between the end product people and the users, and they are talking about the same thing. So the kind of data processing software, I thought there were three categories that are important nowadays. One is the enormously juggernaut processing pipelines, and they produce, of course, science-ready data products. And then, of course, there are the science support applications, which are for extracting science from these SRDPs. And ideally, support scientists generate a lot of these applications themselves and share them amongst themselves, not only within the same institute, but also between institutes. I think that should be a very powerful thing to happen. And of course, in addition to that, there are tinkering applications, and these are for the power users and developers to understand what's actually going on in the software and to think of new things. And I have no idea what direction these will take, but I think it's important to create a possibility for them to make it really easy for people to make these sort of tinkering applications and share the results. Is there a category that I've forgotten? If anybody have another one that I should mention here?
Someone's typing on Discord.
Going, gone. So today's premise.
The definition of power users is a question from Discord, which I think is.
Sorry, I didn't understand that.
If someone can give you, if you could give a definition of power user.
A power user. Well, a power user is somebody who is able, in our little world, to use the best features of all the various packages that exist, and put them together and produce unusual results. You know, very deep images of the sky, and really understand what's going on. So they're much more than consumers. They're people who, you know, that are able to push the boundaries. That's a power user, and also, and of course, they're very computer literate. And that's one of the discussions I had, for instance, this morning with someone, that the problem with this field is that the people who are working in it are so competent that they cannot understand the trouble that users have to use their stuff, to do the simpler things, to find the software and to to figure out the syntax and to see how it works. So a power user is unusually good at that, and of course can do things that most users cannot, and that's a pity. So the premise is that the field is doing rather well because we have high quality algorithms. You should see some of these results that the new radio telescope produces, really impressive. And for instance, in the last 4 or 5 decades, we have improved the dynamic range with a factor of more than 1 million. And that's a bit exaggerated, 4 to 5 orders of magnitude, but that's still impressive. And we use the latest tools and technology, but the field evolves too slowly because we fail to work together effectively. And that is effectively inside our bubbles and between them. And I'll get to bubbles in a moment. So that's the problem. We're great, but we could move much faster because now good stuff is not reaching the users quickly enough. So the conditions for rapid evolution is short time to market. So new software should be quickly available to as many users as possible. That is certainly not the case at the moment. And short feedback loops, that means that users should interact with developers and not with managers. And there should be open competition. Developers should not be confined to a single bubble, but they should have a chance to interact with developers in other bubbles. And of course, there should be low access thresholds for users to actually use the stuff. And that we can improve on all these in all these areas. So we are held back by what I call a multiverse of bubbles. As far as we are concerned, is that our own software package, our own environment, our own telescope is our entire universe. But in the last 20 years, maybe longer, we have begun to realize that that's not the case, that there are other universes. And so we're actually a multiverse. And so we should try to work together because good users and good developers are fairly rare. And so that limited talent that we have in the world should actually work together better, than we can make more progress. Because the problems we face in our various bubbles are very similar. So we have inefficiency between bubbles and inside bubbles. So that's the premise. Can I offer anybody the floor to say something about that?
I would say that's changing quite a bit, Jan. I mean, I don't completely agree with this picture.
Yes.
There is cross-flow. There is a lot of cross-flow.
Yes.
Certainly more than there was 10 years ago.
Yes. Is it enough?
Well, how long is a piece of string? It's never enough.
Well, for instance, if you look at these pipelines, they use features from different bubbles. And so this is probably what you mean.
Yeah, among other things, yeah.
Yeah, and power users like Reinhard van Weeren, he can use features of different bubbles, and he's very much admired for it. But it's a small minority, and these pipelines, once they have all these bits of different bubbles, they have a fairly severe maintenance problem, because these different things, yes, they do work together, but you have to keep an eye on it, because otherwise it stops working very quickly.
Okay, we have a question from Thomas.
Yes.
So Thomas, go ahead.
Yes,
Unmute.
Thank you for taking my question. As far as I can tell, the reason for the bubbles needs to be identified, right? It's one thing that I want to break out of my bubble, but another thing that I get paid actually for staying inside my bubble. If I want to break out, I have to do it on my own time, at home, on Sunday evening, instead of spending time with my better half, right?
Yeah.
The other point that I try to raise is that well, if I develop software, first and foremost, I develop it for the task at hand and not for others. As long as we don't get an agreement with our superiors that they agree, and well, our stakeholders, that they agree, yes, we develop the software not only for ourselves, but for everybody that could be a potential user. Until then, well, the solutions will stay hard to use, will have awkward interfaces that just are usable by the people who wrote the software or who know somebody who wrote the software and so on. So these are two crucial points that I'd like to see to be addressed and identified and figured out.
So can I say that you actually agree with me that it's a problem? The bubble problem?
Yes, but I would take it even further, because you say, yeah, well, we have bubbles. Yeah, but okay, what are the reasons for the bubbles?
Okay, shall I just continue and show you a number of examples of bubbles, and then maybe we can readdress that question?
Maybe we have one more question from Simon. So Simon, go ahead.
Okay.
Hi, yeah, I think we're talking about inefficiency between bubbles. I think it very much, and sort of designing algorithms to be used by other people, it very much becomes about designing interfaces. And it'd probably be a good idea to figure out what those interfaces should look like.
Yes.
I mean, I think probably, you know, the measurement set specification is probably the primary interface at the moment, but perhaps the question is, you know, are there other interfaces that we could think about?
Well, those are excellent questions, and I get to that. You're right that the one interface that we already have and that's very valuable is a common data format, and other fields are quite envious that we have that. But of course, there's also other interfaces like well, user interfaces and ways to jargon and that kind of stuff. So I know that you're working on this stuff. I saw your talk for the RCI the other day. And so I regard you as one of the people who should be part of the solution.
Yeah. Okay. Well, I've got my ideas. I think we're trying it all out. That's the thing.
Okay. But I'm just in the business of identifying a problem, and then of course
Sure.
there's a range of solutions, and but that's the next step.
Okay.
So we agree that there's a problem.
Oh, yes.
Okay, good. We continue. Vladimir Degachev. He's disappeared.
And he can talk now.
Yes?
Oh, hello, can you hear me?
Yes,
We
we can.
can hear.
Yeah, I just
Can hear
wanted to add a couple of comments. First, to introduce myself, I'm actually a physicist searching for gravitational waves. So it's kind of like radio astronomy, but at audio frequencies.
Can you talk a little louder, please?
So I'm a physicist working on gravitational waves. So it's like a radio at audio frequencies. So if you guys are in your own multiverse, I got a multiverse of my own and a big bubble inside of it because there aren't too many others. I wanted to add a comment that I think of this bubble kind of like an electrolytic potential. You have two electrodes, right? And if you put two substances in a solution, chances are you'll have some sort of potential difference and some sort of a bilayer forming and so on, which comes naturally. That there are barriers. For example, when I go looking for astronomical data, I need to get images that are different from what I have. And so there is a natural barrier that goes in. Whatever I write is often, as was mentioned, just for the job at hand for the next paper and then goes. And I also want to mention that this is harder for us because there are just few of us everywhere, just the market. I mean, how many astronomers are there? If you look at commercial software, the best example of a bubble, if you will, would be the databases. So if you want to set up a MariaDB or MySQL for the older name database, you can just download it with a few clicks on your laptop and just have it running. If you want to set up an Oracle database, even if you have the money for it, you have to hire a database analyst, which is a person who sets it up. So it's it's not that uncommon, even in something that is used by lots of people like databases. And so for us, where the software is really written for the next paper, for the next data set, and so on, I think a bubble is expected and might even be considered to be a feature.
Well, here we run into the limits of our format, because it will be fascinating to go into this a little deeper. I would say one thing is that we talk about identifying a problem and thinking about solutions. And in the solutions, you can also say that you start defining things in great detail, things that people should adopt together, or you can, as an in-between, organize access for people, and then they sort out their interaction together. And I think you are in the third category. You want to already lay down how people should interact without leaving that to them, by just making it possible for them to interact. Is that a fair summary?
I think I just was offering a general comment that the bubbles happen and they're for a reason, and maybe sometimes it's good to take advantage of them. I'm not trying to mandate anybody how they should interact. I certainly benefit from accessibility of data from astronomy, and I use tools like Simbad often and ATNF. So having data online, you start looking for it. If it's available, you learn how to use it. Some of the tools are easier than others. Some are more mysterious than others.
Well, we have to move on. I certainly hope to hear more from you, because the emails will be exchanged. And so I would like to talk to you a little bit more about this. Is that okay?
Oh, absolutely. Would be delighted. Thank you.
Yeah, because unfortunately, all these contributions and discussions will not be recorded. So it will be difficult. People will have to follow up themselves. And so the only service we can offer is that we actually have brought people together and identified people that we would like to continue talking to.
Mm-hmm. Well, Jan, to clarify, what we are doing here right now is being recorded.
Okay. Right. Well, let's. Okay. Then we should wait until we see the record and try to make a summary of it. I will move on. Thank you very much. So, a software bubble, as far as I can figure out, is that, here's just a list of some characteristics of a bubble. And the very most important one, often the very most important obstacle between bubbles, is all these different user interfaces. And I've designed one or two user interfaces in my life. It's very amusing, very entertaining work, but people don't thank you for it. And so we have to figure out, we have to somehow overcome that little problem. And of course, different bubbles have their very own operating system, application programming interface, and software rules, and they're all very good, but they're different. And some of them have their very own data format, which doesn't help at all. And we're very fortunate in radio astronomy that we have our data format. And in fact, in astronomy as a whole, we have FITS. In all its humility, has been fantastically important. And of course, bubbles are often associated with a source of pride, like a major telescope or a major instrument or a gravitational wave detector. And of course, you like to stay with your source of pride and not get to and surface that as much as possible. And of course, bubbles have emotionally invested developers and users who, would like to work on their own bubble, as some of you have already said. So anybody else has another other characteristic of a bubble? Garcia.
One raised hand. I can give him the floor. Them the floor. I don't know who it is.
Can you speak loudly?
Hi, can you hear me?
Yep.
That's better.
Yeah, well, I raised my hand before this slide. I just wanted to mention that yes, we are in the situation in which we have different bubbles, because someone else mentioned we have to have common interfaces. I just wanted to mention that having good interfaces is a very tough thing, basically, to have. So in that sense, it's not unusual that we are in this situation in which several vertical stacks have been constructed, and now we are trying to see the commonalities and how to interface between each other, because having a very good interface from the very beginning will be very tough. That doesn't mean that we don't have to try, and that's, I think, this is what we're trying to have here. But I think, yeah, the fact that we are discussing this because it's a tough problem. And the other thing I wanted to mention is that one of the things for conditions for rapid evolution, there was a couple of slides before, is a short time to market, but that is a little bit in conflict with good quality assurance. I mean, if you want to have a good product, you have to have a good quality assurance, and therefore you need actually quite extensive testing, and that sometimes conflicts a little bit with the short time to market.
That's very good. That's a point I forgot. It's, of course, I consider it implicit, but I think you're very right in making it explicit. Quality assurance is very, very important. And I'm very grateful for you to mentioning the magic word of interface, because as you will find out at the end, that's really what I'm trying to steer towards.
Great.
Okay, we continue. So examples of software bubbles. In the old days, when computers were young, there were packages that were developed by single hero developers, often people with of a grumpy nature and very opinionated. And they used to work together with one or two very hard-working users. And they produced wonderful packages, but of course, they were all different user interfaces, different data formats, different this, different that. And so the good bits were distributed over these different packages. And those packages are now still being, they've been very successful, and they're still being run by these aging heroes, and it gets more and more difficult for them. And then, of course, we have packages by herded cats, between managed groups. You know the expression that managing software people is like herding cats. So I adopted this term. Does everybody identify with that? Do you feel like a cat? You can raise your hand if you do.
You do miss the audience nodding, don't you?
Oh, well, never mind. Let's move on. But of course, apart from packages by herded cats, these packages that are managed, of course, the feedback has to go via the manager, which is inefficient. And on the whole, these packages are not enormously responsive because, unlike the hero developer, there's nobody has sufficient overview to quickly do something. And that's been a problem of these managed groups. And then you have a very interesting phenomenon like the cat that walks by himself. It's a story by Kipling. And so it's a very good term to use here. Because the cat that work by themselves, they often produce very interesting software, but they find it very hard to get adopted by a package or to reach the users. And they find it very hard to be rewarded for their work. And so I think we should pay attention to that particular category. And then, of course, there's the processing pipelines. Those are chains of processing elements that are taken from multiple bubbles, and they are a bubble in themselves. Anybody else wants to propose another kind of bubble? We move on. We have another poll. I think this is the third and last. It's a pity because I started to enjoy them.
Okay, that needs action on me again. Sorry, Jan, I'm
I
taking
put the quick link in the chat.
Good, but I think that people are like real cats. They already answered this question before it became appropriate. It's 26 cats at least over here.
I get paid to develop software for it. That's the gentleman before who said that. Yes, that's of course an important reason to be loyal to your bubble.
While we are waiting, by the way, Jan,
he who pays the piper calls the tune.
I was saying, Jan, maybe while we are waiting for votes to trickle in, I see some people putting comments and our questions in the Q&A. Some of them may not be time appropriate, but just pointing out that you could read them.
Well, you have to do that. Is there anything that you feel that should be addressed?
Oh gosh. Someone mentioning it, it's more of a small herd of cats. Like the open source version of the lone cat. I'll now make some comments that the coupling of bubbles to funding is of course a thing that we
It's really, it's so unexpected, the outcome of these polls. I'm very glad that we did them. Next time we'll do more. For instance, I do not understand the question. That's 13 items. It will be very interesting to see why. But never mind, we have no time. We must move on. I'm a bit surprised that it's the bubble of my PhD supervisor doesn't have more in them. Maybe that's a thing of the past, that the supervisor determined what software you used. Because now it's the supervisor that has to follow the student. Well, once we reach 80, shall we move on?
Okay.
And I see a lot of good comments in the Discord, so we can process that later when we write
about
up
this?
our conclusions.
About this one? Peter?
No, in the Discord, I see lots of interesting discussions, comments.
About this particular poll or about other things that we've been discussing?
What we're talking about momentarily and slightly on the chat.
So that is going to be a source of a good summary. All right, so if you guys now leave the poll, then I will, can I share again? Yes. There we are. Share. Here we go. Okay, we move on. So, of course, bubbles have advantages because they're sustained by pride and love. All these people who said that they were being paid by the bubble, of course, that's a form of pride and love. And many of these bubbles actually performed miracles. These early packages were really very outstanding. There was some great software being developed. But of course, they have the drawbacks that the good stuff is difficult to combine. It's scattered over the different bubbles. And there's this thing that these bubbles tend to stop evolving for all kinds of reasons. And lack of resources or just the age of the one developer, hero developer. And then they starve into white elephants. White elephants are products that are difficult to maintain, and they get fewer and fewer users. And it doesn't have to be bad, but in the end, the lack of evolution is the real problem. And that's the premise of today. So I think this is the end of the bubble. Oh, yes. So we have established what bubbles are, and there have been some attempts to escape the bubbles in the past. And one of them that I was closely associated with was the APES++ project, where 7 major institutes, radio astronomical institutes, that ran big telescopes like the VLA and Westerbork, they decided around the early 90s to create a single perfect package that would make everybody happy forever and ever. Of course, that's a very courageous thing to do, but doomed. And so, but we learned a lot from it, and so I'm very glad we went through that exercise. And then, of course, we have another way to escape bubbles is to be a power user. And so you are able to combine features from different bubbles because you're unusually computer literate. And of course, that kind of thing is much easier with a shared data format. But still, it requires special people to do a thing like that. And that's a pity, because then much thinking talent is lost for the cause. And then, of course, there are this modern development towards pipelines. And these pipelines are just modules from different bubbles that are chained together. But the problem is, at least at the moment in these pipelines, is that they have to be designed by specialists who know a lot about these various features that they want to put into the chain. But also they have to, if you look at the definition of such a pipeline, for instance, in the common workflow language, is that lots of the guts of these various things are hanging out, and it's necessary to make these things talk to each other. And that's a major obstacle to maintenance and evolution. So maintenance and other dependency problems are difficult. So the attempts to escape from the bubbles have been, very substantial and done by very good people, but it's still not a solved problem. Does anybody want to say something about this? All right, we move on. So, well, I know, a cat that walks by himself is a Dutchman who's written very interesting flagging and gridding software. And he was complaining the other day that well, he had some of these obstacles that I mentioned here. Of course, you implement your algorithm, and then over here you have to test to create a test environment and get some test data. It sounds trivial, but it's usually a fair amount of work. And then you have to demonstrate its superior performance, not only to yourself, but to others, which is also a lot of extra work. And then you have to find a home for it. For instance, you have to get it integrated in somebody else's system, obeying that's somebody else's bubble, or to get it accepted by a popular pipeline so that it's actually being used. And then you have to maintain it for all these other people's systems, and that's some extra work too. And so it's a great pity that the talent of these cats that walk by themselves is actually hindered, not being fully used by all these obstacles that should not be necessary. So just imagine that all these things would be trivial. How much more productive could they be? Anybody feels like a cat that walks by himself or wants to say something about this?
I see a hand. Vladimir?
Oh, yes. Vladimir, you again.
Yes, I mean, natural, as you might have expected. I have things that I say often, that ideas are reused. Code is rewritten. And I've seen many examples, both in scientific software and especially in open source software. Even in situations where there was a code that did the job very well, I've seen situations where it was written many times, in particular in Linux kernel and other places. The things that actually end up being used a lot and the software that is popular is often the one that is the closest to an idea. So if you think about math libraries that we use, it's really because someplace there was a mathematical model that was devised and that was implemented. Very often I've seen algorithms that people say, hey, I have a great algorithm that would, do something. And when you actually start making use of it, you end up in a situation where it doesn't really provide as much benefit for the effort you needed to do it. It's not close enough to being an idea. On the other hand, I also see situations where people do not really take an idea that is ready and can actually put it to use.
Yeah, so you feel like a cat that walks by himself. You feel close to these obstacles that I just mentioned.
I would say that the obstacles are a little bit different. It's not so much that it needs to be accepted by the systems, but that there are limits towards people expertise and towards the level of competence in the mathematics that is needed to actually get things implemented. So there is these breakdowns that occur from the past from an idea to an actual piece of code that is going to change.
Is there anybody who would like to say something about this? Well, Vladimir, you should write this because I understand that these chats are being recorded. And I think you can also write them down somewhere. So please do this, and then we'll put it into the report. And I certainly hope to talk to you a little bit more about this.
Okay.
You would have been an excellent participant of these FADS meetings that we had in the old days. Okay, we move on. Pilgrim's Progress, the byline of that book by John Bunyan, is From This World to What Is to Come. I would like to put forward the proposition that we should learn from the runaway success of smartphone apps and the Python universe. That doesn't mean that our software is the same as Python, as our smartphone apps, because they're a little bit more complicated than that. But these two enormously successful schemes, they actually present an interface that makes it very easy to use, for instance, applications. That's for these millions of users. And it's very easy for developers all over the world to present these applications and and make sure that they work because they're disciplined by the interface. And the same with the Python universe is that Python is a small kernel, but surrounded by a huge cloud of packages of very high quality that do all kinds of things. And there basically people are disciplined by the Python language, and that also it disciplines them and gives them power. And then again, you have the ease of use by lots of people of all kinds of stuff that they normally would not be able to use, and also lots of third-party developers who contribute. And I think we should study those that kind of successes more and see whether we can learn something from them. So, you know, I stick my neck out and say that after the age of of bubbles, we could enter the age of the shared interface, and where there's freedom and discipline and feedback and incentive. And well, I'll elaborate that in a few more slides, but anybody wants to say something about it now? Garcia.
I just want to mention that we are mentioning here smartphone applications.
Can you speak up a bit?
Yeah, you're mentioning here smartphone applications as a runaway success, but I think that smartphones actually they start as its own silos as well in that sense. No? So might not be exactly the best example as something that has a shared interface. I mean, I'm still struggling to see why I can't use the same applications or common interfaces between my desktop and my smartphone. So it's true that they have make a revolution in terms of user interface and how do we interact with our devices. But I mean, people are still struggling to have common interfaces or writing applications which are common between desktops and smartphones. So I'm not sure whether they are best example in that sense.
Well, I'm not saying that, you know, exactly how you should do it, but I should emphasize that we should look in that direction, because you can see that the two very desirable features there is enormous amounts of users and enormous amounts of developers are somehow achieved. Simon?
And we have a question from Simon. Go ahead. Did I do it right? Allowed. Yeah, go ahead, Simon.
So yeah, I think if we're talking about,
can you speak up also a bit?
Okay, can you hear me now? Am I loud?
Well,
I think in terms of
very close to my microphone and yell into it. I think you should do the same.
I'm going to do that. Okay, I think in terms of the Python ecosystem, definitely what's happened is that all these packages, from my perspective, the common interface is the NumPy array, which is simply a buffer. So almost if we can go to the simplest kind of level, which is like a buffer of data, and write our algorithms to consume buffers and produce buffers, I think that's could be one of the most flexible kind of interfaces that we could come up with. If there are any other interfaces, I'd like to hear.
Yeah, it's true. Python is great. One of my favorite pundits keeps telling me that Python is enough for us, and I try to make the point that we need a little more.
Well, I think it's even more low level than that. I think like the multi-dimensional array, just with raw binary data, it's so simple, and it actually goes back to a C style of programming. If one thinks about it, one is using Python, but it is writing software in a C style fashion. So it might be that in terms of interfaces, we've got to unlearn everything that came from the 90s with object orientation, because that puts abstraction on top of like our raw multi-dimensional binary data. And I think in radio astronomy, we're actually lucky in the sense that our data is big and just often consists of raw multi-dimensional arrays. But those are my thoughts on the subject. So I'll give someone else a chance to speak.
I should think that in radio astronomy, we have the visibility data are not in rectangular multidimensional arrays. Isn't that a problem?
That can be a problem. There are packages coming out there. Are you talking about in the sense that our multidimensional visibility data can vary by row?
Yes. It's a mess.
So there are, yeah. Well, actually, the thing is, there are packages that deal with this kind of nested data out there today, and certainly in the PyArrow or the Arrow ecosystem, nested data formats are supported, and also now there are packages that like there's a package called awkward arrays, which also supports arbitrarily nested binary data. So the Python ecosystem is developing, and as we speak, and it is probably possible to leverage all this development that's going on all around us.
Yes. Yeah. No,
If
I
we don't
totally
just
agree with
think
you.
in terms of a radio astronomy, if we don't just think in terms of radio astronomy, all these packages are being developed across all sorts of other disciplines.
Yes, and most of them have rectangular data. But the point is that it's the interface that is important because it disciplines and rewards. And I think that's the key thing that we should keep in mind. And so the details will then be figured out by the people that we empower this way.
Right, so it's kind of Marshall McLuhan's "the medium is the message."
Yes.
Yeah.
A small time check. We have 25 minutes left.
No, I think we're doing all right. It's thanks to the difficulties of this communication medium, not too many people chip in. But well, I'm not sure whether the people that are still listening in, whether they're fallen asleep or whether they are listening in fascinated silence.
Oh,
There's no
a
way
lot
to
of them
find
are
it out.
writing.
All right, let's move on. So, enter John Lennon. Imagine a single shared interface with one GUI to rule them all. Imagine a single interface for users that gives one-click access to all compute resources in the world, namely software, including pipelines, data structures, processors, and a second click in the same GUI then executes whatever you are trying to access, provided, of course, you have the right privileges, because you know, some things cost money. But it executes because it knows what to do and how to do it and what to do with the results. That's the kind of ideal that that I have in front of my eyes, and that gives huge access to users, makes things very easy, and makes it very easy for developers to offer their stuff to users. So basically, this same, you know, I come back to the same thing all the time. We have to make things easy for users and developers, and then see what happens. So what I described here in the last slide is a single interface for users, but now the same interface for developers. The same interface that makes your software available to all the users in the world, you know, with this one-click access, and it enables you as a developer to be rewarded. Because of course, this is what I hear from the cats that walk by themselves. They work very hard and they're sometimes very much appreciated and famous, but there's, you know, the reward is very meager for all their hard work. And so this interface makes your software available, but it frees you from all the hassle, and that's of course the carrot and the stick. The carrot is that this interface does a hell of a lot of service for you that you don't have to do. You don't have to provide the content, and the stick is of course the discipline that discipline imposes, because if you don't if you don't respect the interface, then you don't exist. So I think those are two enormously important features. Was this? Has this pushed anybody's buttons? Ah, new one. Matthäus. Are you there?
Hello.
Jan, do you have to do something?
Yeah, I was
can you
doing
hear me
something.
now?
My bad. Something went wrong, and it was because of me clicking on the wrong place on my screen.
Okay, Matthäus.
Can you hear me now?
Yes, if you speak loudly.
Okay, yeah. Sorry, I had to click like three separate buttons. So I mean, so maybe I misunderstood sort of the first part about the bubbles, but my worry is that having something like the sort of one software interface, it all sounds good. There'd be a perfect world. You just tell, have access to all of the software and just run it without any worry. But my worry is that in terms of scientists as consumers of the software, if anything, that, in my opinion, would put their bubble slightly even further away from, rather than closer to the sort of software development bubble. And it would sort of alienate them in the sense that, things that, say, I always tell, people, friends of mine and people that I work with, things that we already see in for example, deep learning or machine learning, and a lot of introductory courses, it's explained to people that, okay, this algorithm does this. You don't have to really understand what's going on, treat it like a black box. And my worry is that in this case, having something that's just pretty much point and click, as you said, maybe 2 clicks, maybe 3 clicks, maybe just drag and drop like a UML diagram, that puts scientists as consumers of software and the data further away, because they essentially, that becomes a black box for them, and that removes the need to understand what's happening. As I said, maybe I'm misunderstanding the concept, but it's sort of that kind of my main worry, that it will be putting people further away and actually closing them a bit in the bubble, because it's like, okay, they completely don't have to now understand what's going on behind the scenes. It's really a black box for them. They just set up something, maybe have a minimum setup, put data in and take data out. So yeah, that's kind of my worry.
Well, you're right, and of course there are many such users, but the users of Photoshop, this program that does image processing, they don't understand what's going on, but it's very high quality stuff that they get, and the stuff is high quality because there are lots of people who think they know better and they start testing it, and they can be very brutal in doing that, and that's why the stuff is so good. So if you make it easy, not only for the users to use it, and then hopefully to trust it, but then also for other developers to compete and to make sure that you don't get away with anything, I think that's going to be a very healthy situation.
Yeah. I think I think it's the case of maybe finding a good balance. As you said, like, okay, with Photoshop, people test it, people use it, and most people who sort of push it to the limits test it. I think these are the ones that know their stuff in terms of how to use it, but they don't necessarily have to understand the the exact, what, I don't know, degraining algorithm does or blurring algorithm does. So I think in this case, it's yeah, the case of finding the sort of right balance between that abstraction that we, as I said, my worry is that at some point we'll go a bit too far.
Well, I want to speak up here. I can't raise my hand because I'm on a panelist, but this is exactly what I've been doing with my main package that I released, which is WCS tools to work with the FITS world coordinate system and with catalogs and with FITS files in general. And I made it available 25 years ago, and lots of people use it. Not people don't always know that what they're using is something that somebody else wrote, I think. But a lot, the subroutines are pretty, the subroutine library is pretty high level accessible and pretty well documented and stayed constant for most of that time. At least I hear if I change anything. So, having a lot of users, that was always been my argument where I work, that this is something I sort of did on my own, but it's really work too. And I had to justify it. But one of the things I'd use is just the more users I have, the better it's going to be for us. And if you write it well enough, I mean, I don't know if I'd say well, clearly enough, people can actually send you bug fixes when they send you bug reports, which happens to me all the time. Well, too often probably, I guess. So I think I think this is exactly it, you getting it out. But whether it has to be a single universal interface or just a clear interface is, I think, we're at the point where a single interface, I don't think is going to be totally likely, but having a really clear interface will get the software out in the world. And I think that is something people don't always do.
Okay, thank you. I think such an interface is possible, but well, we have a little bit of time to get to that. But so I sense some approval, at least from two people. Shall we move on? Well, you know, the mantra that I just mentioned is freedom and discipline and feedback and incentive. I just play that out a bit, but of course, well, you can read that later yourself. You might be interested in incentives. You know, the incentives you might crave is praise and fame and employment, which, as we have seen, is just important, and also money. For instance, in smartphone apps, you can earn money by the number of people that use your stuff, and that's something that could work in our case too, especially if you make it in such a way that if somebody makes a composite tool that uses your stuff, that you get a part of the proceeds. And I think this kind of possibility is there, especially, you know, it can be administered by the interface if you design it properly. Does anybody want to say anything about incentives? It boggles your mind.
Well, Jan, I could comment that that kind of market economy that you're thinking of, which mirrors the market, it doesn't work right now in astronomy because we're so much based on agency funding, which has a different idea of how we should do work.
But I think the problem is a lot of us who are writing the software are sort of only indirectly based on agency funding. Like we're funded by somebody who's getting agency funding. So they're going to direct what we do to some extent, but not necessarily exactly what we do or how we do it. They want results. I personally like praise and fame, but employment is really important too. So my most fun software I've gotten from, I get my, I get it. Well, my rewards from praise and fame, but my employment software is usually not as much fun. But else, on the other hand, having a little bit of praise and fame helps me stay employed.
Yes, that's also. Well, you
Yeah,
know,
but Jan, on the other hand, both BoFs before you and after you are related to this model, because the one before was talking about citations and the one after talks about how software can be better discovered and measured, and that, like in ADASS, could feed back into how many citation points, reference points you get, and that could result into something like money, if you wish. Anyway,
yes,
go on. That's just
there's all kinds of rewards.
yeah.
And you're absolutely right. If you create a market, it will be serviced. And then things happen that are sometimes also negative, unpleasant. And so I'm not saying that it should be like this, but I think it should be, you know, it is possible, and it might also have some very good benefits.
Mm-hmm.
Because we're talking about rapid evolution of the field. That was the premise that we say, well, no, the field develops too slowly because there's all kinds of obstacles. And money, of course, apart from being an ugly thing, is also a wonderful thing that makes things possible.
Yeah. So we have a quick question, maybe from Christoph.
Yes, very interesting discussion. I am doing research. I mean, I am a guy working with interstellar medium. I am doing my own code, but I'm using Python libraries, AstroPy or NumPy or Matplotlib. So I am in between, making some programs, but using also things. Well, what I want to say is I just don't know what I will need within the next 2 months or next 2 years or within 10 years. There will be new data, new formats, new paradigms, new law to be tested. So I don't think that everything can be implemented under a single button. You say one another click. We just don't know what we will put on the second click, on perhaps not even the first one. The next 2 years, because new things will appear. We are always pushing the limits. So I'm not sure that the single interface is a solution, but perhaps more a versatile zoo of interfaces, and with people able to manage them. And I think it's very important not to exclude the 5 sigma events, and something which is just click and click, and a very few clicks will always exclude the 5 sigma events, and the 5 sigma events can bring you the Nobel Prize. So take care of not excluding them. Nothing else. Thanks a lot.
Okay, well, that's why we have to try these things, because you don't know yet what my interface looks like. You think it's going to be a very limiting interface, but that's not necessarily the case. You know, the point I've been trying to elaborate is that we have to move towards some kind of an interface that makes it possible makes it easier for users to use and for developers to develop and to get these people together. And of course, that interface has to have certain characteristics, but for the moment, we haven't said anything about that. And but I think we are coming to some kind of an agreement. I sense that, maybe that's wrong, that such an interface would be a wonderful thing. Silence. Yes, Christoph?
Yeah, sorry, I was switch off. Yeah, sure. Perhaps in that case, you mean Python?
No, it's beyond Python. Yeah, I've got 10 more minutes. Shall I get to it?
Yeah, sure. Show me an example.
All right. Here we go. So Well, that's a summary of the first half of the things that I say that, you know, the interoperability is suboptimal between users, developers, and managers, and between bubbles and inside bubbles. But a single interface offers user empowerment, developer empowerment, and a different role for managers. And such a system is sketched below, and it's called proxies. And I claim that it's cheap and painless to introduce and to try. Now, since at least one person asked for it, I will continue. This is, of course, the cartoon that I showed before, which I'm very fond of. And, you know, you see the inefficient people waddling over the ground, suddenly looking upwards, and to see the efficient people doing great things in the sky. So, these are this is the kind of interface that I would propose, and this is the kind of direction I would like you to think. So proxies are interface objects. In my case, I would think of Python because that's just a wonderful system to do these things in. So they're interface objects that know how to interact with a compute resource. And a compute resource is a software module or a data structure or a computer or whatever you can think of. And so these interface objects, they shield the user from all the things that they do not need to see, because at the moment there's much too much of that. And so smartphone apps and Python in a different way, they shield the user from all the things they do not need to see. But the apps these very simple users actually use are very complicated and powerful things. And the only thing they have to do is to find them with a keyword and then say install and say go. Well, that's the ideal, of course, but we want to get as close as possible to get to there. And so proxies, these interface objects, they have a uniform structure so they can be connected to each other, so they can form networks. And of course, because they have a uniform structure, they can be manipulated by a GUI, which only have to know one structure, that one general structure. So proxies, these proxy interface objects, they represent their underlying target modules, and they can test and execute them. They can offer help and documentation, and they can offer many other interesting services. And they're all controlled by a single proxy GUI. And that's all because of all these proxies have the same structure, and they contain the content that is necessary for them and nothing more. And the proxies can also work unattached, unattached to their underlying target modules. And then, there are very interesting possibilities for simulation and system development. So there are two main proxy types: mono proxies. It's a terrible name, I need a better one. And they talk to a specific compute resource, to a specific piece of software or a specific data structure, or a specific computer, I don't know, whatever. And polyproxies that enable sort of pipelines. The pipelines that we have now are linear structures that just chain together features from all kinds of different bubbles, and as best as they can, they try to hide the details of having to do that. Both types, the mono proxies and the poly proxies, are derived from the same proxy class, so that they can be talk to each other and be manipulated from the same GUI. So here I haven't said anything about characteristics of the interface. Just the important thing is that they all have the same structure. And so a monoproxies interface to a compute resource, so a software module, data structure, a computer cluster. And of course they use tools like PyPI and common workflow language and that kind of stuff, because they are very powerful tools, and you don't want to rewrite them or to reinvent them. It's just an interface thing. It uses this stuff, but you don't want the hapless user to actually have to know about PyPI or CWL. It just wants gives the user the possibility to execute it with one click. So these monoproxies do whatever it takes as long as the user is shielded from it. And polyproxies, of course, they interface to one or more other proxies of either kind. So you can have networks of monoproxies and polyproxies, and they can also talk to each other. And the result is so much more powerful than linear pipelines, because they execute possibly a Python algorithm, and they can have loops and conditions and whatever you can think of, anything that you can write down in Python. And so they're much more than linear pipelines. And because the way if you write them, they're much easier to define, because all the guts are hidden inside the proxies. They're much easier, these pipelines, to define and to edit and to maintain. So here's a picture which I hope you can understand. It shows you that the current practice, you have all these, can you see my mouse here? I think you can you? All these compute resources are, for instance, they can be addressed directly by the user or by the CWO pipeline. And in the proxy system, each of these compute resources would have their own proxy here on the right in the oval stuff. And these proxies would be manipulated by the proxy GUI, who manipulates them. And so there you can have one click. I'm getting the idea that I'm not very clear, that I'm not getting through, but never mind. You can see that in front of all the compute resources, there are proxies, and that makes things very much easier and very much more powerful. Is there anybody that I think I should end here, because I can talk a hell of a lot more about this, but we've run out of time. And I'm very interested to see whether anybody has stayed awake to give a comment here.
And the slides are online, so people can dig into it a little bit more at a later stage.
I think they're all comatose.
Oh.
Probably it's a bit, it would be easier to follow with an example rather than so abstract.
Yeah, it's true. I've been amiss there, mainly because, I'm a very poor programmer, as you know, and I'm looking really for someone who can program it for me, because I've been very successful in that in the old days, to find programmers that were much better than me. And that would, I think, very quickly yield to something that people would be impressed with. But as it is, maybe I should try to have it put something clumsy together myself.
Yeah, I was just commenting in the chat to Felix, because he knows that system. This system describing monoproxies and polyproxies in a simpler version, I think, has been implemented in a package called admit, which is a wrapper to Casa.
You should have told me before.
No. I'm just realizing it the way how you explain it here, but in a much simpler way. It doesn't talk about compute resources and so on, but it does have a unified interface, and it allows you also to do a certain operation and implement it in Casa or implement it in IRF. And it's Python based, but it's still much simpler than what you're describing here. You're having a much more powerful interface that knows a lot more about the computing universe. But still, it can build pipelines that way, and it has automatic dependencies and so forth and so on.
All right. Well, you should give me a few more details offline.
Yeah, offline. And I'm not even sure if I'm completely right, because I don't know all the innards of the proxy world. But I'm just seeing a parallel, that's all. And maybe there's other people that say, oh yeah, we've done it this way or that way in R or in Rust.
All right. Anybody else?
There's an interesting question on Discord from James. How would the proxies differ from another bubble?
In principle, they cut across all bubbles, don't they? Because all the knowledge about different user interfaces and so on is in the proxies. It makes no difference for me as a helpless user to talk to my own software with its own proxy and somebody else's software with their proxy, because the proxy looks the same. That's the same uniform structure. Vladimir.
I just want to go back and remember something that sounds to a large degree what you're talking about here, which is a command line interface for Unix, right? So every piece of program you could start on a command line, and there would be some switches and options that you give it, and then it will do something, and then your proxy GUI would basically involve typing these lines one after another. You can either do it by hand, one at a time, or you can take a bunch of them and just put in a file, and that actually becomes your GUI that you start, right? So the
yes,
it can read things, it can write things, and it's easily automatable. It's universal, and to a certain degree, it's pretty close to to what you naturally need. It has a minimal thing that makes bubble a bubble, right? So you need a way to start things, you need a way to pass options, and you need a way to automate things. All goes together. And
yes.
the next level of that I personally very fond of is TCL, right? So TCL is kind of like this Unishell that was designed for adding extensibility to other software, so you can hook it up to a piece of code and just run it. And it looks and works very much like those proxies, right? So you can hook up your piece of software in TCL and then bring up modules and string it. And of course, many languages have similar things, but these things were originally designed to do exactly that. So the Unix shell and shells, because there are many different ones, they're exactly what that is to a certain degree. The only thing is that a lot of people now feel fearful of seeing words on the screen, and they want a pretty picture. And I think that's a bit of a barrier. But otherwise, this is exactly what that does to a certain degree, right?
Yes, well, you talk about command line interfaces, and that's exactly what I try to shield people against, because command lines have syntaxes. And that's if you need a different syntax for everything you do, then it gets very complicated. And so I want to shield people against that. But if you say, well, put a number of lines of the command line in a script, then of course you're beginning to get towards a proxy.
Well, I would say that you never go away from syntax. It's just how you express it. So when you express it via command line, you have this enforced format where you have essentially a character matrix, right? It's an array, right? One line is a one-dimensional array, and you have an array of lines. And you put these numbers there from 0 to 255 if you're using ASCII or something more modern. And then you express them that way. If you're having a GUI interface, like for example, Discord or the Zoom, right? Then you still have syntax. For example, at some point I tried to use a chat. Why doesn't the chat doesn't work? Click here, click there. I learned something. So now I know how to use Zoom. I put some comments into the Q&A instead of chat because the chat doesn't work for some reason. I put some comments into Discord. That knowledge will be lost after this conference is gone, because another conference will do it differently, because Zoom will change, Discord will change, everything will change. And there ain't no way for me to automate that error. The same applies to many other things. The cell phones, for example, I'm an Android user, and I can certainly say that it's getting less and less useful year after year. More things are locked down, less things you can do with it. So my comment here is that one really needs an interface that is going to stand the test of time. And you put in a little bit of effort to learn it, which you need for any interface, for any tool. And the more useful tool, the more complicated it gets, and the more effort you have to put in to learn it. Especially if you want to discover new things that other people have not done, which is what we are doing here, right? We all want to do things that other people have not done before, ever.
Okay, well, thank you. I think we'll have to stop it here because we've already run over our time for 10 minutes. I think I would like to thank everybody for participating. And if you like, we can do it again next year. Maybe we'll have a working prototype town, or what's even better, more working prototypes with people of other ideas. So,
well, so I could, when you say a prototype, if you have, there's always the danger of the hero programmer versus the cannot decide because you have 12 people in a team, is that when you put it on GitHub, a design, people can play and tinker with it.
Okay. I hadn't reached that point yet, but we can talk about that. So
yeah,
don't you think we should end it here?
I think that's good.
I think it's been
I
quite
think a lot of people, I hear a lot of people are interested in some kind of toy model, how this would work. I saw an interesting comment on the chat that said, isn't this Corba? Wasn't this done 20 years ago?
Corba.
So maybe
takes,
in our new
takes me
world.
back.
Say again?
That takes me back, Corba.
Yeah, me too. Dramatically. Well, we can talk about a Tinker model that at least showcase the functionality, and then maybe go from there. I would like that kind of idea.
Well, if we can put a little group together, and that complement each other in terms that I find people who can program a bit better than I can, then I think that would be a great result of this BoF.
I think that will self-organize itself, Jan. Don't worry.
Oh yes, we. Okay, shall we? I'm actually very tired, so shall we put an end to it and say that we'll look at all the stuff that that's in the records,
yeah,
and try to make some kind of summary. I trust
I
that we have all the email addresses of the people that have attended.
Yeah, but the Q&A bothers me. There's a lot of interesting comments in the Q&A. I don't know. You cannot grab the whole Q&A. You have to do it line by line, and then I don't get the username in it. I don't know what the trick is there.
I could do a select all, copy and paste in a VI screen, and I think I have.
It doesn't work on my screen, select all. I only get one person.
It works on my screen. I think one screen is enough.
Okay. All right, you do it.
We'll get there. And I don't know where I'll dump it. Maybe
let's do this online. I have no idea whether these people are still here or whether they've gone to drink some tea or something.
Like you still claim to be here.
Yes.
I think we should officially end it so that people can leave, and then we have some time to copy paste.
Yes, yeah, this session can end. We shall come back.
Please release me. Let me go.
Anything.
Oh. So goodbye, everybody. I'm going to leave the Zoom. Peter and Jan, thank you very much.
Yeah,
thanks, Jan.
And
thank you. I mean,
thank you, Jose, for doing some magic there.
Thanks for all the LOC magicians.
Top share.
Top share.
All right, folks. Thank you so much for the interesting discussion.